Leetcode 128, longest consecutive sequence. Given an unsorted array of integers, nums, so that's our input, pretty standard, an array of integers, so just numbers, return the length of the longest consecutive elements sequence. And that part is actually the hardest part of the whole task, to understand what they really want. So we need to return the length of some sequence. Yeah, so not the sequence itself, but just how many elements are inside. And what do they mean by the consecutive elements sequence? And they will explain in a second. So let's just postpone that and continue reading. You must write an algorithm that runs in O and time. So the time complexity has to be linear. And here is an example. We have 100, 4, 200, 1, 3, and 2. And the output is 4. And explanation is that the longest consecutive element sequence is 1, 2, 3, and 4. So here is the most important observation, is that those elements do not need to come in order. Yeah, so the only constraint is that they themselves need to be ordered in such a way that each one is greater than the previous one exactly by 1. So for example, 1, 2, 3, and 4 in that case. Yes, but from the input we can take them in any order, doesn't matter. And the other thing that's important is that they have to be unique. So if, for example, we had 2 ones, only one would count and the other one has to be disregarded. Yeah? So the order doesn't matter and there are no duplicates. Those are pretty much our 2 constraints, which we can write down in a second. And let's just take a look at the other 2 examples. So here, the length of the input is, I think, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so all the elements are consecutive, and 0 is appears 2 times. Yes, so it's duplicated. And in that case, the output is 9. And this last example is similar to this one, but here 1 was duplicated. So the consecutive sequence is 0, 1, and 2, and the length is 3. Okay, let's just copy that and think about some algorithm that we can use to crack that problem. So let's write down the things that we observed already. And what was that? Numbers and appear in order in the input array. And the second, duplicates don't. So basically, that part of any order, let's make it a bit thinner, already suggests us a data structure that we should use, mainly set. Yeah, so order is not important, and if the second more important thing, if the duplicates don't count, then this is a very strong suggestion that we should use a set. We can even write it down already. So let's put this here together. That's ugly. Well, let's just remove that arrow. Let's just write. Those are big hints to use set. And usually when they are giving an array, we either have to remove the duplicates or maybe sort, but in that case, sorting will not help us, because first of all, we want linear time complexity, so ON, and sorting would take usually at least n log n, and we don't really care about order, so just using set should be good enough to form a proper solution. So we can even already try to transform it here. So how in that case the set would would have exactly same elements as our input. So let's say let's go num set. It would also be like 100 for 200, 1, 3, and 2 if we convert it to a set. But if we added any repetition, let's say if we added here 2, let's say 3 times, then the set would get rid of that duplication. And now, how can we go from this to finding the consecutive sequence? Well, we can iterate through each element and try to find start or the beginning of a sequence. So plus market algorithm. That's our solution. Like that. And how can we find a beginning? The beginning will be the first, the first number from such a sequence will have no number. So the number that's less than that by 1 should not appear in the set. Yeah. So if x minus 1 is not in the set, that's our baby. Or that's our starter. Let's stick to beginning. Yeah. So if, for example, here we would go to them one by one, we could try starting a sequence using 100, but not using 4. Yeah. Why? Because 4 minus 1, 3 is already here. So 200 can also work as a start of a sequence, but of course that sequence would only have one element for that case, but the next one would be the one that we are most interested in, 1. And how do we know that it's a good start? Because there is no 0 inside our null set. Yeah. That's how we can find the beginning, and then try incrementing by 1 until there is until the number x plus 1 is no longer in the set. Yes. And the last part is compare the length of the current sequence with maximum that we found so far. So each time we find a sequence, we try incrementing number by 1 and checking if it's still there. So for example, here, if we start with the 100, then we try to increment by 1, try to check if there is a 101 inside our num set. No, there is no. So the full sequence would only consist of 100. Then we go to 4. 4 is not appropriate beginning because 4 minus 1 is already in the set. So that one we disregard. 200, we do exactly the same as for 100. It could be a beginning of a sequence, but then we increment it by 1 and there is no 201. So the length of the sequence for 200 is 1. There is only one element. And then we start with 1. We increment by 1. Okay, 2 is also here. Okay, increment 2 by 1, we get 3. 3 is also here. Increment by 1, we get 4. 4 is also here. And the length of that sequence is 4. And that's the maximum for that input. So that's more or less it. We just need to convert it to code and we are good to go. So let's do it in a second. We convert num set to nums and we convert nums to num set. We iterate. You also have to create like some counter or some additional variable that we can use to store the longest or the maximum found that we found so far. So let's call it maximum. And now let's iterate for x in numset. If x minus 1 not in numset, then we create another one, y equal to x, and while y in numset, we can remember that one, and then the current sequence length is y minus x, and maximum is equal to max between current maximum and the sequence length, or we can move it here since we don't need it anymore. Yeah, and by the end we return max. Okay, let's try. And let's submit. Submit again. Okay, I'm submitting too frequently, so have to wait a second, but we'll try one more time since I haven't purchased Leetcode Premium, and now we beat 97%. Perfect.